All right, so we're going to explain how this substitution reaction work. All right, so the two professors went back to the lab, do all the experiment, and the observation are totally different from those they observed in an SN2 reaction. Okay, so just to review, so these are the observations. The proposed mechanism have to align or have to support all these observations. Okay, let's see what happened. All right, if you still remember that kinetic evidence of this type of substitution reaction say that there's no direct collision between the two. All right, and the rate is affected by only alkyl halide, the concentration of alkyl halide, not the chloride. So they propose that the nucleophile just chilling at the beginning, doing nothing. All right. If you add more, it doesn't do anything. If you add less, it doesn't do anything. It doesn't affect the rate because it doesn't do anything at the beginning. All right. At the beginning, only the alkyl halide does the work. Let's see what happened. No direct collision yet. Okay. So the first step is bromine relieves. There's a loss of leaving group to form a carbocation. So we call this step a carbocation formation. So bromine leaves, you get a carbocation. Okay, just to remind you, the carbocation is a carbon with an empty p orbital on both sides like that. All right, and then the second step is that's its space right there. So chlorine attack. All right, so this is the backside attack. If bromine's right there, all right, so this is backside attack. So the configuration should be inverted. From an R configuration, you're gonna get an S configuration. All right, but the stereochemistry evidence shows that you get racemic mixer. You get 50% S and 50% R. How do you get the other one though? Well, we're gonna go back real quick. Look at that. So chlorine right here, find there's a space from behind, from the backside, from the backside, you can attack. But there's also space at the front. If you still remember that carbocation is flat. This is flat right here. So there's space at the back. There's also a space at the bottom. Some other chlorine floating around the solution, if they see the space at the front, they go attack. And that makes another configuration product. Okay, you get an R. All right, my point is, this type of reaction is called an SN1 reaction. All right, the first step is a carbocation formation. So bromine leaves, you get a carbocation. That is a carbocation, and they are spaced at the back and at the front. All right, and if chloride, the nucleophile attack from the back, you get the S, which is the inverted from the R, the starting material. If chlorine attack from the front, you get the same configuration. Okay, that's the reason why the product from this substitution reaction is racemic mixture, 50% S and 50% R. All right, so there are two steps here. The first step is carbocation formation, and the carbocation is the secret to why the product you get both S and R, not just S or not just R. All right, so nucleophilic attack, this is the second step. Okay, so they call this type of reaction an SN1 reaction. So S again stands for substitution, N stands for nucleophile or nucleophilic, and and 1 is stands for unique molecular reaction, which means only one species, which is an alkyl halide, involved in the rate determining step, on a transition state of the rate determining step. Okay, that's the reason why if you increase concentration of the nucleophile, it doesn't affect the rate of the reaction, because nucleophile doesn't do anything in the beginning, right? Only the rate also only affected by the concentration of the alkyl halide, just unique molecular reaction, just one species. And to remind you, the rate determining step of an SN1 reaction is a carbocation formation. Right? So bromine leave or a leaving group leave to form a carbocation. Okay. All right. Carbocation is flat, so nucleophile can attack from both sides. Like that. That's the reason why you get both R and S product. All right. Let's moving on.